let's get straight into it. Now, the aims for the end of the lesson are to know how to perform algebraic long division, kind of self-explanatory, and apply it to partial fractions. Or apply it to partial fractions. Let's take a look at the first thing. So, as you can tell, it's algebra and we're dividing. So, 5x cubed minus 6x squared minus 28x minus 2, all divided by x plus 2. This seems ridiculous at first, but there's a technique to it. So first I look at the first term. So that's 5x cubed. Pardon me. And now I look at this x. And I think to myself, x times by what gives 5x cubed? The answer is 5x squared, obviously, but we write it up here. Okay? Because we align the x terms with one another. So if it was like 5x, we'd put it here. Or if it was still cubed, we'd put it here. But it's x squared, so we put it there. And now the next step is to times 5x by everything in the brackets. Or 5x squared by everything in the brackets, sorry. Pardon me. And then we get 5x cubed plus 10x squared. And then we take away. So 5x cubed minus 5x cubed, that cancels out. Negative 6x squared minus 10x is negative 16x squared. And then we bring these two down. And now we do the whole process over again. So, negative 16x squared times by, x times by what gives negative 16x squared? The answer is negative 16x. So negative 16x. And then we times by the whole brackets again, right here. And so we get negative 16x squared. Negative 16x squared. Take away. And that's plus or negative 32x. Right? And then we take away again. These cancel out. And I believe that's 4 or... Yes, 4x, I think. 4x, bring that down. Negative 2, final part. So we brought that down. So x times what gives 4? X times what gives 4x? It's 4. So plus 4. Times by the divisor again. So that becomes 4x plus 8. And then we take away. Those cancel out. And that becomes negative 10. This is our remainder. And this, pardon me, let's just see here, 6x squared. So that's the remainder there. And the bottom part, 6x squared plus 5, that becomes... Sorry, I'm just trying to work this out here. it's kind of jumbling, trying to figure out where each piece goes. So x cubed there, we keep that there. Right, so that's all we need to do right now. I was thinking further steps ahead. So, the next part is... So now we're applying it to partial fractions. So if you'll remember, this is an improper fraction because the degree on top equals the degree on the bottom. So we need to simplify it to a proper rational function for it to be reduced to partial fractions, which we've already learned. So that becomes 2x cubed minus x minus 1 divided by, what's that there? X cubed minus 3x squared plus x minus 3. And then we write it out again. Not enough space there. So 2x cubed minus x minus 1 . Oh, sorry, that's incorrect again. It's late at night, sorry. So since we're missing an x term, we have to put 0 in the ones we're missing. So plus 0 x squared minus x minus 1 x cubed minus 3x squared plus x minus 3. Then we divide that all again. And then this time, so x cubed times by what gives 2x cubed. That's just 2, so we move it right to the end. And then we're finished because the top part of the division has sank lower in terms of degree than the divisor, so that's when we know we're finished. So that becomes 2 times of the brackets here, 2x cubed minus 6x squared plus 2x minus 6. And then we take away all of that, those cancel out, that becomes 6x squared minus 3x and then is that plus 5? Yes. And so how we put this into fractional terms is we take the top part, which is 2, so that becomes 2 plus 6x squared minus 3x plus 5, all divided by the divisor right here, but we're going to simplify it back into its bracket terms, x minus 3, x squared plus 1. And then you can use your skills you've been taught in partial fractions from the last lesson to figure out the partial fractions here, and then you've simplified it, and then in one of our next topics, which is integration, we'll actually use this method to integrate quite complicated fractions, and this will help a lot actually. So it's been quite a short video today. This is something that just requires practice, and you'll get the hang of it just like the snap of a finger. And thank you very much for watching today. I am extremely tired. I hope I didn't bore you all too much. This isn't the most exciting topic in the world, but hey ho, it's maths, and we all love maths. Okay, thank you. Bye bye.